Welcome to the first in our new Blue Label series. This was prompted by some friends in a Facebook group who were having problems taking a big piece of code and breaking it up into smaller units to make it more manageable. So I thought I'd make this to help them out. But first, please subscribe to the channel, click on the like button, click the bell icon to get notified, and support me on Patreon if you can. There's a link in the description below. So Neil Sedaka might think that breaking up is hard to do, and yeah, with relationships it might be, but with C programming it isn't, as long as you follow the rules. Now this is going to be quite a long video, and it's got a lot of technical stuff in there and obviously a lot of code, so feel free to pause at any time and learn at your own pace. Just as an example, there's my firmware for ESP8266. And it's, as you can see, 10,000 lines of code. You can't manage that in a single file, it's just a nightmare. So I manage it in 153 files, which can be even more of a nightmare, but that's why we're making the video. So the major steps, you've got to decide what logical blocks there are in your program. You've got to separate those logical blocks into physical files and then stitch it all back together. That's the kind of thing we want to be doing. So you're going to say, well, what's a block and what should be in it? Well, whatever you want it to be. It's your code. Only you know what you need it to do. But a logical block should match a single well-defined task. It should be completely self-contained and not rely on anything else, and ideally it should do the same thing every time that you call it with no side effects. There's a special word for that, it's called idempotent, and I included it there to make me sound cleverer than I actually am. Now I personally try and make these things the size of a single screen because it's just much easier to work on. You don't have to keep scrolling backwards and forwards, and you've got a single logical concept looking at you. Here's the little program that I have made up for the rest of the video. There's a little thing we've got to get out of the way first. Arduino does things its own way, and that's one of the reasons some people don't like it. What it does is, behind the scenes, it runs main, which first calls setup once and then goes into an infinite loop. And for that reason, you don't ever see a main in an Arduino. And that's why they call the source file a .ino file, because it's not genuine CPP. So I'm going to drop that hot potato and move on to looking at breaking this up into logical blocks. Well, there's our first one. Can't really get away with that. We've got to do something in setup. There's our second one. There's our third one. And there's our fourth one. Now they don't do much at all, do they? But they keep the demo code small. So each of those could be a massive block of something logical. So the first cut we're going to make is to create a C++ function, asterisk, often done by creating a class, but that is something for a future video. I'm going to stick to simple functions with this. That we're going to call its definition. We've got to identify and abstract or take out any common features of logical blocks and make them into their own smaller blocks. Then we create a declaration for each function. And we create a separate code file for each logical block. That's its definition. We then create a header file which includes all of the declarations in simple cases, and then we include that header file in any of those CPP files we've created that uses one of the declarations. So really we need to understand the difference between a definition and a declaration. Declaration is simply introducing the name of a function and its arguments and return type. But it just says to the compiler, at some point in the future, you're going to meet a function called blah, and this is what it's going to look like. It must occur before the declaration in the compilation process. And the definition is the actual function itself, what it does, all of your code. It must match the declaration in every respect, and it must occur after it. Now these rules are features of the C and C++ language. You cannot escape them, and it is these that drive everything that follows. So you have to understand the difference between the declaration and the definition. So pause it here and have a little bit of a think if you need to. That is the declaration of setup. Says to the compiler, hey, there's a thing called setup somewhere after this. The definition is everything that setup does. So the first cut we're going to make is, as you can see, that we have reduced our setup to calling an external function to do the first bit of logic. We have then implanted into the second line another piece of logic called times n in its own function. It does everything that the previous thing used to do, and then we've done a similar thing there by implanting some logic into the overall structure there. So somewhere else in the code there will be function 1, a times n, and an is this easy, and there they are. These are our declarations. They are before the definitions. Now, hopefully at this point you understand the difference between the two and you realise the rules that they need to follow. Now, the Arduino hot potato thing again is that Arduino means that you don't actually have to do that, so some people might not be used to seeing that. But when we start breaking the code up and doing it in real C++, you've got to do the proper thing. From this point onwards, we're going to use VS Code because breaking files up in Arduino is, yeah, I don't like it. It's not easy. It's not simple. And VS Code's a wonderful editor. And Tracy Thorne there with missing is to remind me to tell you that from this point onwards, as you can see, I've left out the definitions of setup and loop because they take up a bit of vertical space and I can't get everything on a screen if I leave them in, and I know it works without them. So let us then move on. So there's the first chop that we make. Just study it briefly, and we've taken all of the declarations, created a separate file called .h, and we have included it in the main code. So we've still got a single monolithic body, but we've made the first step. Here's the second step then, is to cut out each of those functional blocks, which have only got one function in them, but there you go, and create a separate file for each one. So, are you ready to rock? No, because we've done all of these things, but we haven't done that last one yet. So, no, we're not ready to rock. There's more to do. So we need to do that in each of the separate files. Now get ready. Oh dear. Now ignore that last error, that was just me being an idiot. But let's look at these errors. We have a problem here. We've got a thing here that says serial was not declared. And the reason for that is this. It's Arduino again. Serial is defined in a file called it's declared in a file called arduino.h. Arduino IDE includes that by default invisibly in any Eno file. Well, we've just created CPP files, so it doesn't get automatically included. So we've got to go back and include Arduino H in all of our separate files as well. We've got a slightly bigger problem with this one because it can't see, none of the little things can see that life in the universe thing. So let's knock these out one at a time. First one's there, and that allows us to then have like a branch down here where we call Arduino H from the declarations file, because you can nest them like this, and indeed with complex projects you're going to need to. So one include can include a previous include, and that can include it, and it can go so on and so on and so on down the chain. And the reason we do that is because we don't want to have to go and put the Arduino H in every separate file. They all have to include the declarations anyway, so we may as well stick the Arduino.h in there. Okay, and that also brings me to a second point. Notice there that the Arduino.h has got brackets around it, whereas the previous include you've seen had quotes around it, and there's a difference, and it's a significant difference, and you need to be aware of it. The brackets mean search for this library anywhere in the compiler's search path. The quotes mean only look for it in the same folder that the file that called it lives in. We may talk another time about why there's a difference there, but if in doubt with your own files, use quotes. Generally speaking, the quotes are around things that you're going to write to include, and brackets are for library type files. That's just a general rule. It doesn't, it's made to be broken. So we've knocked that one out. We now need to look at this. Life, the universe. That's that global variable that we had. Well, it's obvious, isn't it? We solved the problem, the earlier problem, by including the Arduino H. So we will just take that definition of the life, the universe, and we'll stick that in each of those three files as well, and then compile it. And it's looking good until it doesn't, because it compiled okay, but the linker produced an error, and the error is that there are multiple definitions of life, universe, and everything. Because when it comes to a simple variable, the definition and the declaration are the same thing. So by including that in the H, you've produced three copies of it, and it says, well, which one do you want me to be? Because we know they all equal 42, but one could equal 42, another equal 666. They've got the same name. Which one do you mean? So we now have to start resolving contradictions. And if you haven't listened to that album and you don't know who Andy Mackay is, do it now. So the contradictions we've got are that we know it can't go here because we just tried that. All right, we know it doesn't work there, but we need it here and here. And the way we have resolved this issue is this, using a thing called extern. And that says the definition of this integer called life of the universe that you need is in a file which is external to this file, i.e. the definition is somewhere else. And the somewhere else is here. And the way that C works, there can only be one. In all of the files that it compiles, in those 153 files in H4 plugins, there can only be one definition. You can have multiple declarations sometimes, but only one definition. Now with the int, as I've said, the two are one and the same thing. So we can put in extern reference to the variable and an extern reference to the variable in here, and that will work. That will work, but it's not efficient because they both have to call declarations anyway. All right, like that, remember? So we may as well put it into declarations.h. Now then, that will work, and I'll save time by not showing you that. I know you trust me, but there's a couple of things you need to know that are cautionary. You need to be very careful with the way that you structure your files, because if you do this, and by this I mean you have a declaration here for a class. Let's say there's also a macro being defined, and this piece of code here needs both what's in this H file and what's in this H file. So in this first H file, we've got the class uses this variable that we define, macro, sorry. For completely contrived reasons, this file also needs to use that, but it's done this other thing with it 6 times 2. So it needs the declarations from the first file for used by everyone, and this is easy, but it also needs the declaration from C. Now, whether it's an error or whether it's a kind of accident in doing it this way, what's happened here is that we've effectively done this, all right, and we've got the first declaration in one, and we've got a second declaration. Okay, we've actually included declarations.h twice, and if we include it twice, this happens. We've redefined class C. It's occurred twice, much like the integer can only be one valid declaration for that class within a single branch of that tree that we're compiling. So how do we get around that? Sorry. Sorry, I was getting ahead of myself there, getting excited. I rolled my mouse wheel a bit quickly. Right, we get around it with what are called include guards. Now, there's 2 different ways of doing this. This is the traditional way. It uses these compiler directives, and what this says is this: if there is not defined something called declarations.h, then define it, and here it is, and that's the end of the if. Obviously, if that fails, then it doesn't go and do the middle bit. So if you go through that once, declarations.h is defined. The second time you come through it, when you include the file the second time within the same compilation sequence, it will be defined and it'll get skipped. And that is the way to guarantee that you only ever include the H file once in a compilation unit. There is an easier way of doing it with this special compiler directive called pragma, and I prefer that method because it's cleaner and it's less typing, but not all compilers support it, apparently. I haven't yet met one that doesn't, but I'm just telling you what it says in the rules. Also beware of the snake eating its own tail. Don't include a file which then includes a file higher up in the chain, because it will loop back and it will crash the compiler eventually. But we're ready now. We have knocked out all of the gotchas. We've got everything in place, and I suggest you pause there to look at how it all hangs together. I will talk you through it. Here is our main file. We've got a single declaration and definition of the global variable. That is externed in the declarations.h, and the declarations.h is included within each of our submodules. So that's that one sorted. Now, because you're ready, I just wanted to show you you can do it with global functions as well. So I've got a function here called used by everyone. It lives in the eno file. That's its definition, and that's the one definition that where it's allowed to be, and it's the kind of obvious logical place to put it. and therefore everything that needs it is going to declare it as extern, like that. It's identical to the integer definition, and there it is being used by everyone. So because we're ready now, let's go. And there it is, at last. Now anybody who's seen any of my other videos, especially my rant series, will understand why I chose to put temperature humidity sensor in there, because they're everywhere and you can't get rid of them, and it's one of my little pet hates, so it's my little joke. So the summary: define your functions in CPP files for each logical block. Create an H file at the top of any branch of that tree that needs those declarations. Don't fall into the trap of always just sticking everything in one file at the top of the tree, because that's not always the best. Sometimes you might have things halfway down the tree that are only used by things further down the tree, so put it there. But it has to be above them. H files then almost always are just declarations, never code. Asterisk, it's not true, we'll tell you another time. Quotes are for locals, angle brackets for globals. CPP files almost always are just code, and always, asterisk, etc. need an H file including the declarations of any and all functions that they use. And I'm pretty sure that that wraps it up. I didn't cover a thing called inline, but that's something I'm going to leave you to look into yourself, because the video is 22 minutes long already, so we'll leave it there. And thank you very much for watching. I hope you have found this helpful. If you have any questions on it, you can find me in a number of Facebook groups. Those Facebook groups are linked in the description of all the videos I produced, so I'm not hard to get hold of. And despite being a bit of a grumpy old bugger, I do at least like to think I know what I'm talking about, so feel free to ask.